Hi, welcome to the explanation of new question. This is finding MK average. This is fourth question of weekly contest 236. And this is straightforward question. And this is not that hard a question, but just for the sake of completion, just for the sake that we discuss each and every question that came in the contest, that's why we are discussing it, but it is not that good a question. And you can also see that the framing of the question was not liked by most of the people. That's why number of likes is comparable to number of dislikes. Now coming to the question, in the question, it is given to us. Let me change the color of the pen. Yeah. So in the question, it is given that you would be given two integers. One is m and other is k. Now we have to find mk average for a stream of integers. And there are certain rules by which mk average is calculated. Let me explain those steps to you. So I hope now the font is visible. Okay. So over here, m and k are given to us. And there is a stream of integers which is given to us. Now we have to find mk average for the stream of integers. Now, if the number of elements in the stream are less than m, then we have to consider mk average as -1, right? And if the number of elements are equal to m or greater than or equal to m, then we have to copy the last m elements of the stream of integers to a separate container, right? And then we have to remove the smallest k elements and the largest k elements from the container. And then we have to calculate the average value of the rest of the elements rounded down to the nearest integer, right? So this is the simple question that is given to us. Let me quickly explain this to you with the help of the example. So over here, you can see this is the example which is given to us. And we have to first start by initializing. These are the two values which are given to us. M is given to us as 3 and the value of K is given to us as 1. Then the next thing which is given to us is it is that add an element 3. So we will add the element 3 in our list. Then the next step is to add an element 1 to our list. We'll also add it. Then they want us to find the average. So if we have to find an average, so we were already told that if in our stream of integers, number of elements is less than m, number of elements are 2, which is less than m. So we will simply return -1. So for this call, the mk average is -1. Then let's go to the next step. In the next step, it has given us that we have to add an element. So we will add another element in our stream of integers. Then it is again saying find the mk average. So now the number of elements are exactly equal to m. So now what we'll do is we'll create another container, add last 10 elements to it. Last 10 elements are 10, 1, and 3. Remove the smallest k and largest k. Smallest k is 1, smallest one element is 1, and largest one element is 10. After that, whatever elements are left, we have to find average of that. So we are left with only one element. We will find average of that, which is 3. Now let's move ahead. Now what it is saying is, it is saying that add 5, add 5, add 5. So we have to add 3 5s over here. So let's quickly add 5 over here, 5 over here, 5 over here. Now what they are saying is calculate average. So for calculating average, I have to take last 3 elements and I have to add them in a separate container, remove the smallest one element and the largest one element. I'll remove that. Then whatever elements I'm left with, I have to find average of that. So this is how I find average. The value of average over here would be 5, right? So that's how they have given us. And we don't have to solve the entire problem. What we have to do is we have to implement the class which is given to us. So one is the constructor, because name of the class is mk average. So I have to create 3 functions. One is exactly the same name as the class. So this is the constructor. And then I have to write one function where basically I can add element. and then I have to calculate MK average. So these are the three things that I have to do. And this is basically constructor. This has void return type, and this has int return type. So I hope you have understood the question clearly. Now let's talk about the target complexity. So in the constraints, it is given to us over here, the value of m starts from 3 and goes up till 10 to the power 5. And the value of m is greater than 2k, right? So these are following things which are given to us. And the num is the element which gets added, lies between 1 to 10 to the power 5. And it is also given that at most 10 to the power 5 calls would be made to add element and to calculate average. So these are few constraints which are given to us. Most important is that the value of m is 10 to the power 5. And second most important constraint is that I have 2k is less than m, right? So if there are m elements, then if these are k elements, then these would be k elements. And then I would have a separate set of middle elements over here. So there would be no overlap between the smallest set of elements, the largest set of elements, and the middle elements. This is one important thing that I wanted you to focus on. Other than that, let's talk about the brute force solution now. In the brute force solution, what I can do is I can create a list of integers and I can keep populating them, right? So first I'll add 3 over here, then I'll add 1 over here, then I'll add 10 over here. And then what they will say that calculate average now. So what I can do is I can sort this stream of integers and I can leave the first k integers and last k integers and find the average of below remaining elements, right? So all the remaining elements, m minus 2k elements, I can find the average of those elements. So this is the brute force solution. The problem with this solution is that I would be sorting m times, right? So I would be sorting m times, and this is the time complexity that I would be applying, right? So at most there are the value of m at maximum goes up till 10 to the power 5. And there can be at max 10 to the power 5 calls. So I can say, rather than writing it m, I can say 10 to the power 5 into m log m, right? So there can be 10 to the power 5 calls to find average, to calculate average. And in each time I'm sorting this list. So this roughly gives me, and the value of m also goes up to 10 to the power 5. So this goes beyond my given limit. So this goes beyond, that's why this brute force solution will not work. So I have to come up with another approach which will take less time than this brute force approach. Now I will, because since this is a purely implementation question, there is not much to think about it. I'll talk about the solution directly, and I'll leave the calculation of complexity to you, right? So now let's move to the explanation part. So to solve this question, we would be using an array list. So let's keep a list of integers over here. And this list of integers would be maintaining the last m elements. Because the one thing that we have to focus over here is that we are only focusing on the last m elements. If I have less than m elements, then nk average would be directly -1. If there are equal to m elements, then I have to focus only on the last m elements. So I would be focusing only on last m elements, as you can see over here as well. If I can quickly show it to you. If the number of elements in the stream is less than m, then I have to consider mk average to be -1. Otherwise, I have to copy the last m elements. So the point that I want to emphasize over here is that the elements that are relevant for me are the last m elements only. So moving over here, so I'll keep last m elements as a part of the list. Then for the smaller set of elements and for the top part, I'll create two priority queues. So obviously, if I have m elements and there are k small elements and there are k large elements, then I can say this part as smaller set. I can say this as smaller set, and let's name it as big set. And I'll keep both of them as priority queue. Other than that, I'll also take sum as well. I'll keep sum for them as well. So let's keep sum of smaller set. Let's keep sum of bigger set, and also keep sum of the list of elements. To begin with, all these sums would be equal to 0. Now, obviously, my list of integers would also be initialized to 0. My priority queue would also be initialized to 0. That means by initializing to 0, I mean to say that there would be no elements in these lists. One more thing that we will do is we will take care of the middle part as well. So I would be using a list which keeps all its elements in the sorted order. So I would be using, in Java, there is an implementation, there is a variety of hash map, which is called as a tree map. So I would be using tree map over here, and I would name my tree map as the middle elements. So let's name it as middle. And it would have, it is a tree map. It basically keeps all its element in sorted order. So we'll get to know why I'm using my middle like this, but we need to understand that I need to get the smallest element of my middle elements and the largest element of my middle elements. So that is the point why I am using tree map, which keeps its element in the sorted order. So this sorted list is required over here. Now let's talk about, talk about our running example only. So in a running example, we had 3, we had 1, we had 10, and then 5 was added, then 5 was added, and then 5 was added. Now let's try to solve it this way. So first what I'll do is I would talk about this part. I'll add 3 into my list. So when I add 3 into my list, now I have to check whether the size of the list is less than m or is it equal to m. So for that, I'll also keep one more element, which is, or rather than it's not required to keep. This list that I have required, this has a property of size as well. So I can directly check what is the size of my list. So I've added this element and I can see that it is less than m. The value of m in a running example was 3 and the value of k in a running example was 1. Now let's try to solve it ahead. So as we can see that at this point of time, my list size is less than m. So since it's less than m, so what I'll do is I'll keep this element in this smaller set as well as the increasing set, because you can see that when the count of elements is less than m, or I can say when the count of elements is less than k in one of the set, then at that point of time, I can say that there would be overlap in both these segments. What I mean to say is now there is only one element in my list, which is 3. So if I try to find smallest k numbers or the largest k number, then this 3 would be included in both the list, right? Now let's move ahead. So I have included them in both the list. Now let's add 1 into it. As soon as I add 1, now what will happen is, now the first thing that you have to understand over here is that still my elements are less than m, right? So still if somebody tells me to calculate the average, then my answer would be straightforward -1. But over here, one thing that we have to see is that smallest list is 3, 1. So smallest k integers. So smallest 1 integer is not 3 now, it should be 1. And the largest k integer should not be 3, like it should be 3 only, but over here it should be 1. So let's try to figure out how this is taken care of. So what I'll do is I'll try to figure out what is the right place for it. So I have 1 in my hand, the element which needs to be added. So over here we need to see like which is the best place for it. So I would check that the size of the element, just a second. Now this element needs to be added. So first what I'll do is I'll take this element and I'll add it over here, right? After I add it over here, then I'll check that whether the number that I have, or let's not add it. Let's not add it over here. So this is the element that I have in my hand. Let's check it with the priority queues value. So what is the priority queues peak value? So the peak value would be the largest value in the smallest element, right? So this has to be made max priority queue. I'll let you know the reason. And this has to be made as the minimum priority queue, because an element which enters needs to be compared with the smallest value of this priority queue and needs to be compared with the largest value of this priority queue. Let me give you a more concrete reason. So let's suppose we have these elements. Let's suppose we have 10 elements. Now these, the value of k is equal to 4. So these form the largest 4 elements and these forms the smallest 4 elements. If a new element comes, whether it belongs to this part or not, who will decide? Whether it belongs to this part would be decided by the largest element of this block. If it is smaller than the largest block, then it needs to go into this block. If it is greater than the largest block, then it needs to go somewhere over here. So that is the point that I wanted to mention. If somebody needs to go into minimum priority queue, then that will be defined by the largest element of the small set. So that's why I have to make this maximum priority queue. I compare 1 with the max of this max priority queue, which is 3. And I found out that this value is smaller than that. So 3 would be removed and 1 would be inserted over here. And this 3 would be taken from here and it would be inserted over here, right? But before doing that, one thing that we have to notice over here is that this element removed over here, I'm trying to add it over here, but 3 is already there. So what I'll do is I will check the value of k is 1 over here, and I'll always make sure that if one element is added over here, another element should be removed from here, right? Because this maximum set, this big set, should always contain k big elements, and the small set should always contain k small elements, right? So these are the two things that I wanted to focus over here, right? So this one will be removed, this would be added, and the minimum priority queue's peak element, the smallest element, would be removed. So 3 would be added and 3 would be removed. So our small set would look something like this, and our big set would look something like this. Then let's talk about 10, right? So as soon as 10 comes, then this is the point where my list size is exactly equal to 10. As soon as my list size becomes exactly equal to 10, then I have to think over the fact that if there are m elements in my list, then there would be some elements, k elements, which are in my small set, and there are k elements which are in my big set, and I'm left with m minus 2k, right? So now let's add this element, but after addition of this element, we will get to m equal to 3. So this element would basically come over here. It will first try to, I will first try to add it in the small set. But when you try to add it in the small set would not occupy it. It would not allow it because the peak of the small set is 1, and this is greater than the peak element. Small set always contains less than or equal to its peak element. Now it will try to come over here, and exchange will happen over here. So this element would be reduced by, would be exchanged with the peak element of this minimum priority queue. So this would be 3, 3 would be ousted from here, and 10 would be included from here. Now what you need to do is, now is the time when I need to add my middle elements in my tree map. When will I add my middle elements in my tree map? I will always add my middle elements in my tree map when my size of the list is exactly equal to m, and I have k elements over here and I have k elements over here. So one simple question that I have to ask from this position is that, is my size of the list greater than 2k? If the size of the list is greater than 2k, then is the only point when I will add this element to my tree map. Otherwise, I will not add this element to my tree map. So over here, I'll add this element to the tree map because size of the list becomes 3. And this is value of k is 1. So 3 is greater than 2 into 1. So that's why I'll add this element into tree map. And over here, I'll add its frequency as well. So this frequency is something that we can easily manage. Okay, other than that, one part that we have missed so far is we have not updated sums. So let's quickly update sum. So this would become 1, this would become 10, and over here the sum would become 14. Now let's suppose if somebody tells me to update or calculate the average, then it becomes pretty simple. If I want to calculate the average, then my average would be equal to the total sum, which is 14, and I have to subtract the summations of these two elements. This is 1 minus 10. So this gives me 14 minus 11, which is 3, divided by m minus 2k. So that is what I have to divide, right? So sum of elements divided by number of elements. The value of m is 3 and 2 into k. The value of k is 1. So 2 into 1. So I would be given 1. So 3 divided by 1, average comes out as 3, right? So that's how my average will be calculated. Now let's quickly talk about one other example. So let's add another 5 over here. So let me quickly erase most of the part from here so that we have some clarity and we can easily work on our question ahead. So let's suppose I have to add another element 5 in the list. One thing that I'll strictly focus over here is I would not go beyond m elements, because there is no point going beyond m elements. So if a 5 is added over here and before addition of 5, the size of the list is exactly equal to m, then I need to work something else. So the size of the list is exactly equal to m and I have to add another element 5. So the first thing that I'll do is I'll remove the first element and let's keep this in our hand. So this is the second case that I have to work upon, right? There would be only these two cases. The first case is the point where my size of the list is less than m. For that, we will do whatever we have been doing so far. And if the size of the list is exactly equal to m, then I'll first remove the 0th element, right? So I have removed the 0th element. Now the 0th element has to be removed from other places as well, right? So let's try to quickly remove it. First place that I have to remove it is from the sum. So my sum would become 11. Now I have to check whether my middle slot contains it or my small set contains it or my large set contains it. Because I've already told you that this is the point where my list size is double equal to m. Now the element that I'm containing or that I'm handling in my hand, the 0th element is 3. So it can either be in the middle part or it can be in the small set or it can be in the large set. There is no overlap over here. So it can be in either of the one case. So I'll check if it is in the middle part. So I'll remove it from there. If it is in the small set, then I'll remove it from here. And if it is over here, then I'll remove it from here. So one thing that we have to focus over here is when I'm removing it from here, let's suppose this element 3 is found over here. If I'm removing it from here, then I'll take one element from middle and I'll add it over here as well, because I have to always maintain k elements over here and I have to always maintain k elements over here. And if I'm removing it from here, then I'll take one element from here and add it over here. That is one part that we have to focus on. Other than that, now let's talk about the new element. So the new element that I'm adding is 5, right? So when I'm adding the new element, so before adding the new elements, let me quickly erase this part because I have removed it from my middle part. Now 5 is added. So obviously I'll add 5 to my list. So after this has been done, now I have to ask myself where basically this 5 has to go. So again, the same part will happen. Again, the same part will happen. This 5 will come in between. It will first try to go over here, right? It will first try to go over here. It would not be able to go. It will try to go to this big set. It would not be able to go over here as well. And since the size of the list is greater than 2k, so obviously this element will go over here. So it will come as 5, 1. Now if somebody tells me to calculate the average, so what I will do over here is, if somebody tells me to calculate the average, so I'll take the summation, which is 11 plus 5, which is 16. Now 16, I'll subtract 10 and I'll subtract 1 from here. I'll subtract the summation of small set and I'll subtract the summation of the big set. This will give me 5, and I'll divide m minus 2k because the number of elements in the middle set is m minus 2k, and this would give me 5 divided by 1, which is equal to 1, right? So this is how this question has to be solved. Right now, let me quickly take you through the implementation as well. So over to the implementation part. If I take you to the implementation part, so I have to take this part and I have to focus over here. So over here, first you have to see that I have created these elements. The implementation in Java, but you would be able to understand. So over here, you can see that I have taken m and I have taken k. Then I have taken a list of integers and I have named it last m. Then I have taken a tree map and I have named it middle. Then I have taken a priority queue smaller k and I have taken a smaller sum, a long smaller sum, priority queue larger k and long larger sum and a long sum, right? This is for the sum of the integer. Now I have written this constructor over here. Over here, I have initialized everything. Right? By default, Java has a minimum priority queue. That's why I have left my larger k as it is. But over here, my smaller k has to be made maximum priority queue. That's why I've written this constructor over here. I have added this way, right? So this is one thing that I wanted to talk about. This is to change the natural ordering and to make max priority queue. Smaller k is max priority queue and larger k is minimum priority queue. Now let's come to this part. So there were two partitions that we were talking about. One where the size of the list is exactly equal to m. If the size of the list is exactly equal to m, then I'll do something else. This is the number that needs to be added. And if size of the list is already equal to m, then I'll do something else. And if the size of the list is less than m, then I'll do something else, right? So let's talk about that. So if size of the list is double equal to m, then I'll do something else. So let's quickly talk about when size of the list is double equal to m. So when size of the list is already m, then I'll first remove the first element. After removing it, I'll remove it from the sum of the entire list as well. Then I'll check whether this part is in the middle or it is in the smaller set or is it in the larger set. If it is in this middle set, then I'll basically remove it from the middle set. And if its frequency becomes equal to 0, then I'll completely remove it from the middle set, right? Middle set is, you can say it is hash map only. And if it is in the smaller set, then I'll remove it from the smaller sum. And then I'll get the first element from the middle set. I already told you my tree map is a sorted list. So if I want to get the smallest element from my middle set, I have to do middle.firstKey. And then I'll add it into my smaller set, right? And I'll add this element in the smaller sum as well. Similarly, if that element which needs to be removed is to be removed from the larger set, then I'll remove that element from the larger set. I'll remove its summation. Then I'll get the last key of middle. I hope you are getting this point. And I'll add that element to the larger of these elements, right? This is which is to be done if the size of the list is double equal to m. Now let's move ahead. So if the size of the list is double equal to m and this transition has been done, then what I'll do is then I'll move to these parts, and these parts are common, right? These parts are common. These parts are to be done if the size of the list is equal to m or less than m. So I'll obviously add that element at the end of the list. I'll get that element's number. I have written it in another variable called add to middle. I'll add it into the sum, right? Now I'll check over here whether smaller k dot size is less than k or not. If smaller k dot size, if the smaller set is less than k, that means there is complete overlap between smaller set and larger set. So that element needs to be added in both smaller set and larger set. If there is no overlap, if the smaller k dot size is greater than k, then I have to check whether that element needs to be added in smaller set or in the larger set. That element could be added in the smaller set as well as larger set as well. Like for example, it can happen that the value of k is equal to 3 and there are these 3 elements and the list contains 5 elements, right? So if the list contains 5 elements only so far, so it may happen that there is still an overlap. It may happen that there is still an overlap. Larger set contains 3 elements and smaller set contains 3 elements and there is still an overlap. So if there is a new element which has come, I'll try to add and I'll check whether it goes into smaller set as well as I'll check whether it goes in the larger set as well. So at each place I have written if, right? Okay, so this was the part that I wanted to mention. But one more thing that I had done over here is I have added it in the middle set as well. It would be added in the middle set only and only if the size of the list is greater than 2k, right? So that's how it is done. We only add to the middle set, to the middle tree map, only if we have more than 2k numbers, right? First, we try to, if there are less than 2k elements, we make sure that we are not adding it to the tree map. Because if there are less than 2k elements, then there is no point in making that. I will only be populating my smaller set and I would only be populating my larger set. Now there is another function which needs to be written, which is to calculate mk average. If somebody calls this and if last m dot size is not equal to m, then I directly return -1. Otherwise, I'll calculate this sum. From the summation of the complete list, I'll remove smaller sum and larger sum, and then I'll divide it by m minus 2k, right? And since it has to be rounded off to integer, that's why I have done this typecasting. So this is how this question was to be done. Now the part that I want to leave up to you is to find the complexity of this solution. This was an easier question. It was a purely implementation question and it should not have been this hard question. It should not have been given as hard in this competition. It was not that good a question, and explanation of it also took a lot of time. And I had to resort to walkthrough of the code because it was a long code. I could not write it, and explanation and writing would have taken time. So that's why I have just given you a walkthrough. I'll share this code and I'll leave up to you to find the complexity of this code, right? If I quickly run this code, you will see that it would be accepted. So this is the small test case which is accepted. And if I quickly run this code, it is not that time efficient, but still it is accepted, right? It runs faster than only 16 or 17% of Java submissions. So it is not that efficient, but still it is accepted. So that is one part that I wanted to talk about. I hope you have understood this. Thank you.